Hello everyone. So today we are going to work on this 𝐒𝐻𝐻 system. So as you can see here, the characters can smoothly clear out as the characters move around the world. The 𝐒𝐻𝐻 is smoothly cleared out. Here is the demonstration. This happens with all the characters. For example, if I move this guy over here, you can see that the fog is getting cleared. See, so yeah, this is what we are going to work on today. So in the first part, we will work on how to spawn this, how to place these clouds to cover the entire world, and then let's look into how to remove as the characters move around the world. Okay, so last time we tested this clouds objects. So now that we have implemented the clouds, I want to next look into how to implement a 𝐒𝐻𝐻 system. So usually 𝐒𝐻𝐻 is implemented with using render textures and completely masking some areas, but instead of doing it that way, I want to try like adding actual fog over these clouds, and as the player goes around the world, clear out those clouds. So that's the way I want to do it. I want to try it at least and see how it works. So for that, let's first start a blueprint, act a blueprint pp 𝐒𝐻𝐻. Now I'm gonna lay the clouds throughout the world as instanced static mesh components. So first, let me delete these clouds. I don't need them anymore. So here I'll add a instanced static mesh ISM clouds, and here I'll set the cloud as the mesh. So I'll add a function or an event, custom event, place clouds. So if I am calling this again and again as I make changes, and if I am to call this in the construction script, first if I already have some instances, I need to clear them. So clear instances, and then we need to add instances in a grid. So for that, I'll add a variable grid size. This I'll make a vector 2D. So this will represent the size of the grid. As default value, I'll put 100,000 by 100,000, and then I'll add another variable that defines the gap, like the cell size of the grid. So I'll call it gap between two cloud instances in the grid. Then using this grid size, let me split so we can get x and y. Let's divide this by 2. By doing that, we can get the midpoint and if I divide this from the gap, we can get like the number of cells or number of points along one direction. And if I do this, do the same thing for the y, we can get the number of points along y-axis as well, in with the gap between two points, same as the one we define here. I'll set it like 3000. Now, so we can run a for loop. So here we have grid size. For example, let's say I give the grid size 10 and I give the gap 1. So by dividing 10 by 2 and dividing by 1, I get 5. So if I consider 0 0 as the midpoint, 0 0 or whatever the place where we place this 𝐒𝐻𝐻 blueprint, I can get a plane that this point that the location of the 𝐒𝐻𝐻 blueprint is the middle point of that plane by doing something like this. Here I'll multiply this with -1, so and use that as the first index, and as the last index I'll use the same value. So we will get a loop that is going from, according to the previous value, example value, -5 to +5. And similarly, I can run another for loop for the y-axis, same way, -5 to +5. Okay, now again, to get the location that we need to spawn our cloud, we can get the x value by multiplying this from the gap. So this gives the x coordinate, and multiplying this from the gap gives us the y coordinate. So now if I get that location and add a vector to this, let me split this. So here we have y value, here we have x value. If I put these two values, I can get a point around this blueprint location in a grid. So here let's add instance of these ISM clouds. Let me split this. I'll use this location and I'll keep these other stuff same as the default values, and I think we should use world space. Right, now I'll call this place cloud function in the construction script. Let me place 𝐒𝐻𝐻 blueprint here. I'll make this one also public. I didn't get the clouds as I expected. Here let me add a debug line before spawning the meshes to see what's going on. This is the starting point and end point should be somewhere above the same point. file, take this file, compile. Oh, we only get here. Why is that? See, we only get a single line here. Oh, sorry. Why did I use a multiply here? It should be an addition. That should be the reason. Yeah, now no, still not correct. It's correct. I haven't connected the starting point. Yeah, now we have an ice cream. Okay, so now if I connect this here, I should get the clouds. No. Oh, yeah, I still have to connect this. Yeah, here. Now we have the clouds. Okay, now let's modify the values. So we only need, let's try 40,000 by 40,000. Yeah, that's enough. And the gap 1000 too close, not enough. So I'll add some randomization and scaling for the clouds. For that we don't need this debug line drawing now. This one, let's randomize. Random float in range between 0 and 360. Oh wait, this may not work. Let's multiply a value with 90 because we are our shape is a square. The cloud shape is a square, so having any degree wouldn't be a good idea. So we have like multipliers of 90. So here random int, let's have a random int in range, so between 0 and 4 inclusive. Now we would have clouds with different degrees of multiplications of 90 and the scale. So here let's add a multiplier and float in range. So I'll promote this min scale and max scale. So these are cloud scales. So min scale I'll define 2 and max 3. Okay, min scale should be 2. Right, now everywhere is covered. But if I reduce this to that seems better. Not enough. Alright. But when I have a smaller scale, I sort of see a pattern. So 2 to 2. Oh, now we almost don't see a pattern. So I think this scale is better. Now we need a way to clear this for before. So do we have collisions for these clouds? Okay, I don't really need such a complex collision, so let's remove the existing one and add box. That should work. Now here instead of block call dynamic, I'll use custom and ignore everything except, let's say, this camera trace. Oh no, visibility. Right, now I'll define a blueprint interface. PP interfaces. I like to keep a different folder to define interfaces. PPI fog of wow. Clear fog, and here we need to tell which fog, which instance of the cloud we need to clear. So let's say index. This should be an integer. There is a way to determine which index we need to clear. So for that, let's first implement this interface here. PPI fog4 clear fog. So let's just simply remove it. Remove instance. Okay, so now let's go to our character, this top-down character. Here, actually, not just this character. Usually, we need to clear the fog of 4 from multiple characters and also from buildings and other stuff that we place in the world or create in the world. So let me define another folder, fog of 4. Put this to here. Then I'll create an actor component AC fog checker or fog cleaner. Now here what we need to do is let's add a custom event check fork. So here all we need to do is to align trace by channel from whatever the actor that owns this component. So get owner, get actor location. Perhaps we should add some offset from the character, so maybe with this ignore self it wouldn't be a problem, but just to be safe I'll add some offset and let's trace upward. Let's say 10,000 units using visibility channel, and if we get a hit we can break, and on the hit actor we can call clear fog index. I think this hit item gives the index of the instance of cloud, right? Now we need to call this, so no need to call this in everything, that would be a waste. So I'll add a timer, timer by event, set timer by event, let's say every 2 seconds or 1 second also fine, and need to load. We can give the event like this. Now I'll add this fog cleaner into the character, AC fog cleaner. Right, now let's see now it's clearing out, and if I move the character, oh, I can't move, yeah, because my controller is responding to the visibility channel to get the location that we need to move the character. So let's change this. Instead of visibility I'll use camera. I think this should be query only, fine. And here we should use the camera channel. If we want we can add a custom channel as well. Right, now let's select a character. Yeah, it does work. However, since my camera has some angle, see, it would be better if it clears this area as well. So, and also I can rotate the camera, so it's still blocked, I can't see the character. So I think it would be a good idea to do another trace from the character towards the player camera location instead of going upward. So let's do 2 traces. Let me collapse this to a macro so I can easily reuse it. trace clouds. Okay, now same as before, starting point is similar, but the endpoint here would be get player controller, get camera, player camera manager, get camera camera location. Right, this should work. Let's see. Yeah, now it clears nicely. Yeah, that's better. And even if I rotate the camera, the cloud will be cleared. So if I rotate, see, it's clearing out the clouds. Okay. Alright, that's good. Instead of just making the cloud vanish, I think it would be a good idea to like fade out the clouds, but I will do that part in the next episode. So thanks for watching. As always, project files will be available for the download in the Patreon page. Link would be in the description below, and if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.